Welcome to the final section of Unit 5. Here, our focus will be word problems. We will see how fractions and mixed numbers can pop up in everyday life. Yes, we encountered several word problems as we progressed through the first 3 sections, but for those word problems, we knew what operation we had to use, given the lesson we were in. Now, we'll have to make a choice of operation prior to completing any calculations. And please do not stress over word problems. Do not freeze like a statue when you see one. Here are a few tips. As you work through word problems, please read closely, rereading as many times as necessary. Highlight key information you are given. Highlight what it is you have to find. Decide on any operation or operations necessary to solve the problem. Choose a method to help explain or illustrate your solution. And please, have fun doing them. Problem number 1. While making dinner, Pierre has 3 recipes requiring flour. The first recipe uses half of a cup of flour. 3/4 of a cup of flour is needed for the second recipe, and 2/5 of a cup is required for the third. In A, how much flour does Pierre need to make all 3 recipes? Let's first of all highlight some of the key information we're given. So I know I'm going to have to use the half of a cup, the 3/4 of a cup, and the 2/5 of a cup. What operation are we going to use here? Well, if I look at my question, how much flour does Pierre need to make all 3? So the all 3 gives me the idea that I need to find the total. And if I'm finding the total amount of flour that I need, well, that's going to imply the use of addition. So we need to add the 3 proper fractions we've been given. If I add up a half of a cup and 3/4 of a cup and 2/5 of a cup, that will give me the total amount of flour that's needed. In order to add these 3 proper fractions, we need to draw now from what we've learned in this unit. I know that to add fractions, I need a common denominator. My denominators right now are a 2, 4, and a 5. I need the LCD. Well, the LCD for 2, 4, and 5 is 20. If you need to list out your multiples of 2, 4, and 5 to figure that out, that's okay. Do what you need to do. So now we need to rewrite these 3 fractions with a denominator of 20. Half, the equivalent fraction will be 10 over 20. 3/4, the equivalent fraction will be 15 over 20. 2/5, the equivalent fraction will be 8 over 20. I copy down my LCD, add up my numerators, and I get a 33 out of 20. That's an improper fraction. Let's convert it back to a mixed number here. So 33 over 20, how many full 20s can I get out of 33? I can get 1, and that will then leave me with 13 20ths. So my answer, 1 and 13 over 20, and 13 over 20 is simplest form, so we can now write our final statement. Pierre needs 1 and 13 20th cups of flour. B. Pierre has exactly 2 cups of flour. Does he have enough? Will there be any flour remaining? And if so, how much? 2 cups of flour, which is what he has. That's a key piece of information. So we need to first of all compare 2 with 1 and 13 over 20. If he has 2 cups, does he have enough? My goodness, yes, because 2 wholes is definitely bigger than 1 whole and part of another. Pierre has enough flour since 2 is greater than 1 and 13 over 20. Will there be flour remaining? Yes, there will. If so, how much? Well, what operation will allow us to figure this out? Well, if I got to figure out the remaining, I'm going to have to subtract here the 2 cups that he has, and we take away what he's going to use, and that will tell us how much is left. Now we need to subtract 1 and 3/20 from 2. What I'm going to do here, I'm going to use the method whereby I rewrite the 2 as a 1 and 20 over 20, which is still the equivalent of 2 wholes, and I subtract the 1 and 13 over 20. That allows me to subtract the whole number parts. 1 minus 1 is 0. But 20 subtract 13 still gives me a 7 out of 20. So how much flour is remaining? Pierre has 7/20ths of a cup remaining. So he can still do a little baking if he wants to, depending on the recipe. Our second problem here. Last week, Taylor worked 5 2/3 hours babysitting and 3 3/4 hours giving swimming lessons. How many hours did Taylor work in total? And express your final answer as a mixed number. Key pieces of information here. Well, the hours that she spent babysitting, the hours that she spent giving swimming lessons. And in determining what operation to use, in total. As soon as I see that, I'm thinking addition. So we need to add those two mixed numbers, 5 2/3 plus 3 3/4. The process or method that you use for this, again, that's up to you. I'm going to use the method whereby we're going to rewrite our proper fractions first with a common denominator. My LCD for 3 and 4 is 12. So I'm going to go 5. And I need an equivalent fraction for 2/3 as something out of 12. So 3 times 4 is 12. 2 times 4 is an 8. 4 times 3 is a 12. 3 times 3 is a 9. That now allows me to add not only the whole number parts, which gives me 8, but now I can also add the 8 and the 9, which gives me 17 over 12. If I look closely at my answer here, I see that in my fraction part, I have a numerator that's larger than my denominator. So that's not a proper fraction, that's an improper fraction. So we should not leave our answer like this. We can get another whole out of the 17 over 12. I can split the 17 over 12 into a 12 over 12 and a 5 over 12. This 12 over 12 then gives me another whole, which I can combine with the 8 to give me 9 wholes, and I'm left with 5/12. If I double check my fraction here, that is lowest terms, so this is indeed our final answer. So a statement, Taylor worked 9 5/12 hours in total. And now I'd like you to proceed to the next video in this lesson.